All right, 3.1 measures the central tendency. Measures the central tendency are things that kind of talk about the middle. You're talking about mean, median, and mode. We're going to interpret the data, explain what a mean, median, mode all tells you, maybe which one to pick, which one's better, and whatnot. We'll talk about some different types of means as well. There we go. So average indicates kind of the middle. So here we go. Mode, median, and mean. The mode is the number that occurs the most. So here I got 16 students that are asked how many college math classes they have completed. One occurred the most, so it's 1. It is possible to have a tie for mode. You could have 2 modes. It's possible you have no number repeat whatsoever, so you could have no mode. Median, the middle number of an ordered set. Now that's the biggest thing, is oftentimes I get kids that give me the median just by looking at the middle number of the data as it was seen or given to you. You have to make sure that it's ordered. Typically you go from the lowest to the biggest. Equal number of data above and below the median. Uses the position of the value rather than the actual data value. It's a nice number to use because it doesn't get affected by an outlier as much or extreme values. Okay, so here we go. You got your median, like I said. You're going to order from the smallest to the largest. For odd number of data, the median is in the actual middle. For even, you might have a number that's not in your data, or it's the average of the middle two. For any data set n, so whenever you see this lowercase n, that means that you got like a sample mean or sample set there. The position of the middle number is n plus 1 divided by 2. So if I've got 5 numbers, 5 plus 1 is 6, 6 divided by 2. The third number in should be my middle number. Okay, so here we go. Here's a set. 7 cans of soda removed from packaging plant contain the following measurements. It's already in order, but take away here, and I kind of work my way down to the middle. And because it's an odd set, that 12.1 is my median. So I've got 3 numbers below, 3 numbers above. Okay, now I've got 8, an even number. So what I could do is 8 plus 1 is 9. 9 divided by 2 is going to be 4.5. I could go 4.5 in. But I kind of like going 1, 2, 3, 4, just kind of side by side. Oh, wait, I'm not going to have a middle. So you take those middle 2, add them all up, divide by 2. You're basically taking the average of the middle. And 16.15 right there would be down the middle. And there's 4 numbers below. There's 4 numbers above. Okay, the mean is used. It's basically the average. The mean uses all the data to calculate the measures of the central tendency. Kind of get into some notation now. Whenever you see X bar, it's a sample mean. So like all the data you got on your project was from a sample, so you'd use X bar to develop that. But if I want to talk about all the Cheyenne stats kids, that would be a population mean. I'd be talking about mu. Okay, they're calculated the same way. You get this Greek symbol. It's capital E looking thing. It's called sigma. It is a summation thing, so you're going to add the numbers up. With population data, you'll see a capital N. With a sample data, you'll get a lowercase n. But basically, your sample mean, so for like X bar, it's add all up the data and divide by how many there are. Population mean, add up all the data, divide by how many there are. Okay, it's all kind of about notation. So 7 light bulbs are measures to see how long they last in hours. We want to find the average light bulb or the mean value. So add up all these numbers, get 1,221, divide by 7 because there's 7 light bulbs, and get an average of 174.43. Now, the problem with this is we have resistant measures that will not be affected by extremely low or high values. The mean is very susceptible to an extremely high number or an extremely low number. So oftentimes the median is used, or we use what's called the trim mean. Okay, so if you're to trim something, you would kind of get rid of. And with the trim mean, it's usually a certain percentage of data. So to find that percentage, you're going to take whatever trim mean, usually it's 5% or 10%, and you're going to multiply it by how many sets of data you actually have, or how many number of data you have. Okay, so if I've got 20 numbers, that in a 5% trim mean, I'm going to take 5% of 20, which is 0.05 times 20. That works out to be 1. So I'm going to get rid of so remove the lowest and highest one number. So the 15's out and the 110 is out. You're going to go through and you're going to add up all of these numbers that are left, and that's going to be on the top of your fraction. But now you're going to divide by 18. And the reason why you're dividing by 18 is because you have two fewer numbers. So the trim mean is 72.78, and the actual mean was 71.25. Okay, your weighted average. Okay, so at times maybe you want to have more categories or categories weighted more than the others. We do this here at school. Like quarter one has got a weight of 40%, quarter two has got a weight of 40%, and your final test, your exam, is 20%. The top part would be to take each value and you're going to multiply it by its associated weight. Okay, and then what that big E is going to tell you is to add them all up. And the sum of the W is typically 1. So here in a pageant, the interview is worth 30%, the appearance is worth 70%. What is the weighted average for the contestant with an interview score of 90 and an appearance score of 80? Okay, so how that's going to work is you're going to take your 90 times its appropriate weight. Make sure that 0.3 is used instead of 30. And the 0.70 times the 80. You're going to multiply those together, get 27.56 divided by basically 1, and you get a weighted average or weighted score of 83. So that's kind of your different ways to do average. Here's some problems that you can work out. They're odds, so the answers are in the back of the book, and good luck with that.